the isomers. The next question will be asking, draw two structural isomers of compounds with the formula C3H7Cl. This is an alkene attached to it one halogen atom, and the halogen atom can be placed in different places to make different isomers. So we can put it at carbon number 1 in one isomer and carbon number 2 in the second isomer, and take care, if you put it on number 3 it will be still called 1-chloropropane, so it will not be an isomer of the first one. So you have to put it first on the first one or in the middle only. Draw the structure of two structural isomers with the formula C4H10. This is an alkene. The only way to do an alkene is to make branching. What does it mean? Is that instead of having 4 carbons in the normal butane, you'll have to make 3 carbons in the main chain and the branch coming out from it. The only place that branch can come out of is number 2. If you make it from 1 or 3, it will not be a branch. It will be still 4 carbons attached to each other. These two are isomers, have the same molecular formula, different structural formula. The formula C4H8 represents two structural isomers named isomer A. So this is the regular butane. What's meant by the term structural isomers? We have just defined this at the beginning. The alkene with the molecular formula C5H12 can exist as a number of structural isomers. Draw structures of two isomers. So in order to make an alkene, the only thing you can do is branching again. So the first one is C. 2, 3, 4, 5, and then you will add the hydrogen atoms. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbons. Now in order to make the isomer for that, as we agreed, choose a less number of carbon atoms. So that's 1, 2, 3, 4, and then the branch will be coming from any one of that. You cannot put it here. It will not be a branch. If you put it like that, this is not a branch. A branch can only come from here, a second one, or this one. So I'll put a carbon here, that's a branch, and then that's now the total of 5. Then continue drawing the compound as normal. This is CH3 coming from here, and H from here, H from here, H from here, here again, H and H and H. Now count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Both of them is 7, 5 H12s. This one is called a pentane, but this one is, let's number it, 1, 2, 3, 4, and at number 2 there is a methyl group. It has 1 carbon only, so it is a methyl. So at number 2 there is a methyl, and the main branch is 4, so it is 2-methyl butane. These are two isomers. Again, alkanes, the only way to do isomerism is by branching. Draw the structure of two structural isomers formed when 1 mole of chlorine reacts with 1 mole of propane. So the first thing to do is to make the reaction. When you add 1 mole of chlorine, one hydrogen atom only will be replaced. So meth is prop, that's 3, and then one of them will be replaced. So it is Cl plus HCl. Take care, only 1 atom will be replaced. Then this is the first compound formed. The second isomer is by again changing the position of chlorine. So instead of being on number 1, that's 1, 2, 3, that's 1, 2, 3, it will be on number 2. So the chlorine will be here instead. Don't put it here, don't put it here or here, it is the same thing. So just put it on the second carbon. Now it will be 2-chloropropane. So 1, 2, 3, and this is number 2. Are these two compound isomers? Write their names. Now this is alkenes. Alkenes is very easy to make isomers. All you need to do is to change the position of the OH. So it is at carbon number 1, and it will be here on number 2. Still the same. In order to check if they are isomers or no, C3 and C3, and how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's H8 and 1 oxygen atom. That's the alcohol. So alcohol is very easy. Just change the position of the hydroxyl group and explain why the following two alcohols are isomers. They are isomers if they have the same number of carbon atoms. They have the same molecular formula, 1, 2, 3, 4, 2, 3, 4. So they have the same molecular formula. Hydrogens are 1, 3, and 3, and 3 is 9 and 1, 10. Here 3 and 6, 3, 4, 5, 6, 7, 8, 9, 10. So also 10. And one oxygen, both of them, they have the same. So they have the same molecular formula. Do they have the different structural formula or no? Yes. Here it is attached to carbon. This carbon is 1, 2. So the maximum is 1, 2, 3 to count. But here 1, 2, 3, 4. So different branches. That's why it's not the same compound. We have the same molecular formula but different structural formula. All you have to do is write the definition of the isomer. Thank you and see you in the next video.